Our next example involves an indeterminate difference. Notice that if we try to evaluate this limit with direct substitution, we get 1 over a little bit larger than 0, so positive infinity. And then the next one is shifted to the right, and 1 over a little bit larger than 0, so another positive infinity. Infinity minus infinity. Since this is indeterminate form, we can't determine an answer from this step. We have to do more work. So a typical strategy when dealing with indeterminate forms of infinity minus infinity is combine the two infinities, the two terms together somehow. And in this case, since we're dealing with fractions, a good idea would be to get a common denominator and combine the fractions together. So the common denominator is ln of x times x minus 1. So the first term is missing an x minus 1 on the numerator and denominator. So we have x minus 1 over x minus 1, and then times the ln of x in the denominator. And over here we're missing an ln of x, so top and the bottom by ln of x. Like so. We can write all of this as one fraction. And hopefully at this point it gives us a different type of indeterminate form. So using direct substitution, I have 1 minus 1 minus 0, a little bit bigger than 0, over 1 minus 1 times 0, which is 0 over 0. Well, that's good news. We have an indeterminate form of a different type. This type we can use L'Hopital's rule. Taking the derivative of the top, we have 1 minus 1 over x. Taking the derivative of the bottom, we have a product rule. Derivative of the first times the second plus the derivative of the second times the first. Let's use a little bit of algebra, see what we can do with this. On the bottom, we have ln of x, and then I think we will distribute the 1 over x. At this point, we can decide what we want to do. If we'd like, we could get common denominators of x on the top and on the bottom, or we can try direct substitution again. If we try direct substitution again, we will see that we have indeterminate form of 0 over 0 again. So the top gives us 1 minus 1. The bottom gives me 0 plus 1 minus 1. Since we have 0 over 0, we can use L'Hopital's rule again. Derivative of the top gives us x to the negative 2. The derivative of the bottom gives us 1 over x, which I'm writing as x to the negative 1, plus x to the negative 2. And this isn't very convenient to look at, but it works just fine since my x value that I'm approaching is positive 1, and positive 1 to the negative power is still positive 1. Even if you square it, I can apply direct substitution and get 1 to the negative 2 divided by 1 to the negative 1 plus 1 to the negative 2, which is just 1 over 1 plus 1, which is 1/2. And we have a limit.